Hello everyone, welcome back to a new episode of Advent of Code 2016. As you can see from the terminal, we are still on part 2 of day 17. Haven't gotten started yet on writing this paths function. Of course, we're going to reuse the node interface from the breadth first search. And I'm going to try writing it recursively. Actually, I want to try something before I do that. Pass. What happens if I write like def my map fx to be yield from itertools dot imap fx? Like, is that a thing that exists in this version? No, that was added in like Python 3 or something. So you can do the same thing without yield from, but yeah, okay. So we're just gonna, it's gonna be a little bit gross, but we can write this paths function thing. So what do we do exactly? We don't need a queue, that's for sure. We don't need this iterations count. Oh, I forgot the iteration stuff is still here. We're I hope we don't get that far, because then it's gonna. If we ever get to like 5,000 or 1,000 or whatever path length that was, it's gonna start making a mess. Something I was a little surprised to see. I was looking around at my computer's task manager, and this Python process is using like 20 or 30 megs of memory. I would have thought that churning through all these options, we would be using more memory than that. And I don't know, does that mean we're going too slow or what? Like, I don't know. It seems like there should be a lot of paths. But I guess that there aren't necessarily a lot of paths, right? Because we're supposed to be able to search through literally all of them in a reasonable amount of time. And so I think just maintaining this priority queue is what's costing us all the time. Wait a minute. What if we just put them into an ordinary queue? Is that going to help at all? I think actually. So the usual way that you transform a breadth first search into a depth first, no, you transform a depth first search that is recursive into one that is iterative by creating your own stack. And we already have that algorithm written. It's using a queue instead of a stack. And won't it be the case that if we just tell it, hey, use a stack, we will have exactly the same algorithm as a depth first search, but without the stack size limitation? Right? I think that's true. So let's try it, I guess. So Python stack. I think there's something in the queue structure, queue library as well, but I don't know. Let's just go see. Lists, stacks. Tell me about stacks, please. Stack. Using lists as stacks. The list methods make it very easy to use a list as a stack, where the last element added is the first retrieved. To add an item to the top of the stack, use append. To retrieve, use pop without an index. Is that efficient? They say it's easy, which I agree with, but is it efficient? I don't know. Okay, well, the next section says using lists as queues. You can use them as queues, but lists are not efficient for this purpose. Appends and pops on the end of the list are fast. Okay, so it looks like we can maybe just use a list. So let's let queue instead be this while q I feel a little bad that we're now what is it that I'm trying to say? Well, I was going to say that we're removing our solution to part 1, but we can fix it. We're going to cannibalize our search function to be one that just explores everything. So let's call it paths instead. While q, and we'll call pop. And we'll still store the same stuff on the queue, even though we don't really care about all of it. So we pop, and instead of put, we'll call append, and that's all, right? That's our paths function. And it's still like using this goal estimate for no real reason, so let's get rid of that. And instead of estimate, we'll even get rid of the estimated cost completely. Spent cost and node. So we could do a little bit more here since we don't really care about the costs either. But they're convenient enough to hang on to, so we might as well. So while q, pop, okay. And then what we'll just do is say low equals solutions dot next, high equals low, and then for solution in solutions, if solon dot, well, actually, low equals, is there a, oh, we'll just use max and give it a two item list. Max of low solon key equals len, should be min. Max equal, or high equals max of high. And we'll just print both parts here. Part 1 percent s. Whoa. I have some misbalanced parens somewhere here. Part 1 percent 2 percent 2 low high. Right? This seems okay. I'm going to start another terminal here so that we don't interrupt the one that's running, just in case it is productive. You guys can't see this right now. If it becomes interesting, I'll try to change that. Name search is not defined. Well, you are right about that. It's now called paths. Not enough arguments for format string. Sure. Guess it's got to be in a tuple. Okay. Whoa, okay. It yielded a lot of things. Oh, this print should be outside of the solution. Okay. So it's churning through... Oh my goodness. All right. We need to cancel this one right now. It is... We found paths of length like in the thousands. Oh man. Okay, well... Here you go. So that earlier solution was just never going to work. Am I crazy? Like... Why does this ever terminate? Did I misunderstand the problem completely somehow? How robust it is. You want to find longer and longer paths. So let's look at this here, right? You decide to find longer and longer paths which still provide access to the vault. You remember the paths always end the first time they reach the bottom right room. They can never pass through it, only end in it. And then they give a couple examples and say, like, hey, the longest path would be 830 steps. But as you can see, we're finding solutions of length like 20,000. There's just simply no way that we're going to be able to explore like 4 raised to the power of 20,000 different paths. And there won't be in practice quite so many, but it will still be a lot. So this tells me that we somehow have a problem, I think, in our implementation, because these paths are just disgustingly long. So, are we missing something? Oh, we are! Oh, okay. Okay, well that's good. I'm glad that it was so easy once we stopped to ask the question. We are appending the new cost. Since earlier, see, this was a return statement, this yield. It was okay to do whatever we wanted after it because it would never be reached. But now we're continuing to search even after we found the exit. And I guess that makes enough of a difference that it becomes solvable versus not. So we just want to put an else here. And try again. Yeah, oh, that's way better. Okay, that made the difference. Holy cow, wow. All right, so we can get rid of this print here. Run it again. Sure, let's time it even. There you go. How long does it take? 1 second. Okay. Well, give me this, please. That's not the right answer. Wait, what was the question? What is the length of the longest path? Oh. Echo -n of this pipe to word count -c, please. 618. Okay, well, I have to wait a minute before I can type it in. I feel bad. But okay, so, boy, that was a bit of a red herring. Well, let's do some git maintenance here. Import editor tools. Yeah. Git commit. Day. Hello, typing. Why is he taking so long for me to type a thing? Day. I guess when OBS is up, it uses a ton of CPU, and so running all this byte elisp is like a problem. I don't know. Day 17, part 2. Replace search algorithm with exhaustive traversal. And what else? I guess that's the main thing. Sure. All right, we should be able to type 618 in now. That's the right answer. Okay, great. So here's our calendar. I don't know if you guys have looked recently, but we got a monorail going along. The tree, is it colored now? It is colored. A minute ago, I don't think it was colored, but maybe I just didn't look very closely. Also, like a few puzzles ago, there was no tree here. There was different stuff going on. Like this was apparently a parking lot a while ago. I don't know. So I don't really understand what the cityscape is changing into, but sure. I guess it's all Christmassy. This is gonna light up at the end. That's gonna be real nice. Oh, you guys can't see it. The star at the top. I can't point. Here you go. This one right here. That's gonna light up. That'll be fun. Just 7 puzzles left, huh? 8, I guess, because we haven't done 18 yet. Okay. Well, anything more that I want to say about this? I guess the main thing is that it was kind of cool to note that we don't actually have to rewrite our traversal algorithm to change it from breadth first or A star to depth first. if we had started with a depth-first approach, you usually write depth first in terms of using the stack and recursion, and that's fine and great. But if it sort of implicitly uses the program stack as the only place where you can store state, and if you are explicit, you externalize your state into a state variable, a data structure that you're keeping track of while you iterate. You can actually vary your search algorithm quite a lot without changing the code, just by changing the data structure you use. Right? If you have a stack, you're basically doing a depth-first search using that stack instead of the program stack. If you have a queue, you're doing like a breadth-first search. If you have a priority queue and a good cost algorithm, then you're doing like a directed search, finding the best cost. So that's something to like maybe keep in mind. I don't know. It took me a while to think of it, but then I realized like we don't have to rewrite our traversal at all. Anyway, there's a little bit of philosophical rambling. A pretty short episode, but not super duper short, so I don't plan to edit it back into the previous one. Thanks for watching. Hope you guys enjoyed, and I will see you next time.